Hello and welcome to Algebra 1, Lesson 16. In this video, we're going to learn how to find the slope of a line. So in our last lesson, we learned how to graph a linear equation in two variables. Kind of the next thing we want to learn how to do is take this graph, right? It's always of a line, that's why we call it a linear equation, and analyze the steepness, right? The steepness is referred to as the slope. So I have here that a very important characteristic of a line is its slope. Let me highlight that word for you. It's slope or steepness. And you might not have run across this yet in your math class, but you've seen it in your everyday life. You can think about being on the interstate and seeing a 10% downgrade sign, right? What does that mean? Well, it means for every 10 miles you travel, the road has dropped by a mile, right? That's what a 10% downgrade means. Your road is going to look something like this. It's slanted downward, right? I know that's not a perfectly straight line, but let me draw a picture of a little car here. And just for the record, I am a terrible drawer, and I know that. So this is my car here. And I'm put a little exhaust going out of there. And I'm driving, and for every 10 miles I go, the road is dropping by a mile. So that's an example of a slope. All right, so we measure slope by comparing the change in y values. This is the vertical change. Remember, the y-axis is a vertical axis. To the change in x values, the horizontal change. Remember, the x-axis is the horizontal axis, while moving along our line from one point to another. All right, so how do we actually calculate slope? Well, lucky for us, we have something known as the slope formula that we can use. And then we can also do it using the graph, which we'll cover in a little while. So calculating slope, and this is using the slope formula. You're going to pick any 2 points on the line. Doesn't matter which 2 points you pick. So this means any two ordered pairs. And you're going to label the points as x sub 1, y sub 1, and x sub 2, y sub 2. Now let me stop. I'm introducing some new notation, so I want to clarify. This right here, this one that's kind of sitting next to the x, is read as sub 1. This 2 that's sitting next to the x is read as sub 2. This is a way for us to notate that we have two different x values that we're thinking about here without actually kind of changing variables, right? And in a lot of math, I can just pick a variable, a different letter every time I have something else I'm representing. But here, because we're specifically thinking about, okay, the x value is the value that we're thinking about that corresponds to the horizontal axis. So I've got to be consistent there. I can't say, okay, I have x and then I have some variable named z. That wouldn't make any sense. So we have to have two different x values. And so to separate them, we use sub 1 and sub 2. If I was working with something that had three different x values, I would have a point that would be x sub 3, y sub 3, right? So on and so forth. And you're going to see that as you move higher in math when it calls for that. But for right now, we just need 2. So that's where this is coming from. So you have x sub 1, y sub 1, and x sub 2, y sub 2. Now, the next source of major confusion is which point do I label x sub 1, y sub 1, and which point do I label x sub 2, y sub 2? And the answer is it does not matter, okay? And I'm going to show you that so that you understand, because I can't tell you how many people come up to me and say, well, how do I know which one to label as which? It does not matter. You can switch them around. You're going to get the same exact answer. So once you've labeled them, all you need to do is plug it into the slope formula. And I advise you to copy this down. We have that m, which stands for slope. This stands for slope. And I don't know why m stands for slope, but it does. And this is equal to, we have y sub 2 minus y sub 1. So this is referred to as your change in y values. And then this is over, or you can think about it as dividing by x sub 2 minus x sub 1, which is what? It's the change in x values. Okay, the change in x values. So we have the change in y values over the change in x values. And then one important note, we can never have the case where x sub 2 equals x sub 1. Why? Because we can't divide by 0. If I have the same number here, Let's say 2 and 2, 2 minus 2 is 0. I can't divide by 0. So that's a problem. So x sub 2 cannot equal x sub 1. And another way we might see this written is that m, our slope, is equal to the rise over the run. And this is just a way to remember that it's the change in y values, or the rise, you kind of think about this as going up and down, over the change in x values, or the run. You kind of think about running as going, sideways, or horizontally, being on that horizontal x-axis. All right, so let's start out with 2 points. This is a typical example of something you see on your homework or tests. You're given 2 points and you're asked to calculate the slope. So we have the point -1, 1 and 20, -20. So the slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'm not going to write this every time, but remember that x sub 2 is not allowed to equal x sub 1. It cannot. All we need to do is label one of these points as x sub 1, y sub 1, and the other x sub 2, y sub 2, and then just plug in. Again, it does not matter which point you choose to be x sub 1, y sub 1, and which point you choose to be x sub 2, y sub 2. It's completely irrelevant. You get the same answer either way. So I'm going to pick this to be x sub 1, y sub 1, and I'm going to pick this to be x sub 2, y sub 2. One thing that you cannot do, okay, you cannot mess this up in terms of saying, okay, well, this is x sub 1, y sub 2, and this is x sub 2, y sub 1. That will give you the wrong answer. Do not do that. If this is x sub 1, this has to be y sub 1. If this is x sub 2, this has to be y sub 2. Right? You cannot mix those numbers up like that. Now, once you have labeled everything, go ahead and just plug into the slope formula. It's really just that simple. So I have y sub 2 here. So I'm going to take -20 and plug that in. So let me just erase this and just put a -20 here in its place. And then I have minus, I have y sub 1. So that's 1. Let's erase this and put 1. And then I have x sub 2 down here. That's 20. So I'll erase this and put 20. And then for x sub 1, I have -1. So let's erase this and put a -1 in. Now, again, it's very important to pay attention to your signs when you're plugging in for something. I already had a negative out in front. I'm plugging in a -1 for x sub 1. So it's minus a -1. Don't make the silly mistake of just seeing that out in front and just putting -1. You get the wrong answer. So then all I need to do now is just simplify. I have -20 minus 1, which is -21. And this is over 20 minus a -1, which is the same thing as 20 plus 1, which is 21. So I end up with -21 over 21, which is the same thing as -1, right? -1. So m, again, my slope, let me label that real quick. My slope is equal to -1. So let's see if we can make a little sense out of this slope thing. So we saw that m is equal to -1. So what does that mean? Well, again, if you kind of look at the rise over run explanation, so rise over run, we know that we can write -1 as -1 over 1, right? That's the same thing. If you divide by 1, it's just itself. So I can put this as equal to -1 over 1. So I look at what's in the numerator. I have rise here and I have -1 here. So that means I'm going to rise by -1 or fall by 1 unit for every run, which we think of as going sideways, by 1 unit. Okay, now because this is positive down in the run, that means I'm going to the right. So positive in terms of the x-axis means you go right. Negative means you go left. Positives in terms of the y-axis means you go up. Negative means you go down. So if I started out at a point on this line, so we know that -1, 1, which is going to be right here. So that's a point on the line. I could actually use this to graph the line because I know that I'm going to fall by 1 unit. So I'm going to fall by 1 unit, thinking about the rise. For every 1 unit, I go to the right. So I'm going to go down 1 and over to the right 1. So this point would be on that line. And I can keep doing that. I can go down 1 to the right 1. And go down 1 to the right 1. Down 1 to the right 1. down 1 to the right 1, down 1 to the right 1. Or another thing I can do, remember, when we're dividing and we think about having a negative in the numerator but a positive in the denominator, I can legally switch that. Right? I can legally say that this is 1 divided by negative 1. Now, how would we read that? Well, that means that we would rise 1 unit for every unit we go to the left on the x-axis. So starting out at this point, I would go to the left 1 unit, and then I would rise a unit. We see we end up at a point on the line. Left 1, up 1. 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 And I can keep going. Left 1, up 1. Here's another point. Left 1, up 1. Here's another point. And you can see that I could easily draw a completely straight line through those points. And let me do that real quick. Not perfectly straight, but you get the idea. And later on, we're going to learn how to take this information that we have and find the equation for the line. So this is actually y equals negative x. And I know that you don't know how to do that yet. That's okay. We're going to learn it very, very soon in the future. So quickly, I want to show you that if I switched which ordered pair I labeled as x sub 1, y sub 1 with the ordered pair I labeled as x sub 2, y sub 2, that it would make no difference and your slope would still be negative 1. Let's do that real quick before we move on. All right, so let's just switch the way these are labeled. And so instead of this being x sub 1, y sub 1, it's going to be x sub 2, y sub 2. And this is going to be x sub 1, y sub 1. And let me erase this real quick. So the slope formula, again, it's m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And let's just crank this out real quick. So y sub 2 is now 1. So I'm going to plug that in. And minus y sub 1 is negative 20. Again, pay close attention. You're plugging in a negative 20. So that's going in there. And then this is over x sub 2, which is now negative 1, minus x sub 1, which is 20. Minus 20. Okay. So what are we going to get? We have 1 minus a negative 20. That's the same thing as 1 plus 20. That's 21. This is over. Here we have negative 1 minus 20, which is negative 21. So again, you see it's going to be the same thing. 21 divided by negative 21 is negative 1. So this is negative 1. Or again, in terms of slope, we could think about this as negative 1 over 1. Or we could write it as 1 over negative 1. Right? Again, as it relates to rise over run, we've already seen that we can use that in 2 different ways. All right, let's take a look at the next problem. So we have the ordered pair, negative 7, negative 11, and 5, 5. So these 2 points are what we're given, and we want to calculate the slope. So m, again, our slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And again, x sub 2 cannot be equal to x sub 1. So we're going to label our points. And a general practice for me and probably for you is just to label the first point as x sub 1, y sub 1. And again, as I just showed you, it doesn't matter. You get the same answer either way. And this one's going to be x sub 2, y sub 2. Okay, so y sub 2 is 5. So let me erase that and put a 5. Minus y sub 1, that's negative 11. Let me erase this and put negative 11. And this is over. We have x sub 2. That's going to be 5. Minus x sub 1, which is negative 7. So minus a negative 7. So in each case here, we have to pay close attention to our signs because we have minus and negative. So 5 minus a negative 11 is the same thing as 5 plus 11, which is 16. 5 minus a negative 7 is the same thing as 5 plus 7, and that's 12. Now, we can reduce this. Both are divisible by 4. 16 divided by 4 is 4. 12 divided by 4 is 3. So we get 4/3 here, or 4 over 3. Now, we think about this in terms of, again, rise over run. So rise over run is equal to 4 over 3. So that means that if I'm at a given point on a line, I can rise 4 units or go up 4 units and then run 3. So go to the right 3 and I'll end up at another point on that line. So a point on the line is 5, 5. So that's going to be right here. And again, our slope, m, is equal to 4/3. So in terms of rise over run, this is 4/3. So if I wanted to find another point on this line, I could go up 4. So up 1, 2, 3, 4. And then I could run 3. Okay, when you talk about run, again, positive means you go to the right. So I'm going to the right 3. 1, 2, 3. So here's another point on that line. Now, let's say you are out of space going up on your graph, like I am. My kind of top number here is 10. Well, no problem. You can start at 5, 5, and you can go in this direction. You might say, well, how do you do that? Well, one cool trick is to remember that a negative divided by a negative is a positive. So really, I could write this as -4 over -3. This has the same mathematical value as 4/3 because if I divide a negative by a negative, I get a positive, which is what I have here. So using that thought process, I could start at this point and I could fall 4 units, right? That's what -4 means in terms of rise. So I would go 1, 2, 3, 4. And then I could go to the left 3 units. That's what -3 means in terms of run, right? I'm going to the left. So 1, 2, and then 3. So here's another point on the line. And I could do that again. I'm going to fall 4. 1, 2, 3, 4. I'm going to run to the left 3. 1, 2, 3. So here's that. And then I could graph this line if I wanted to. Okay, and again, not perfect, but kind of the best I can do. All right, and then what's the equation for this line? Again, I know that you don't know how to figure that out yet, but I'm just going to go ahead and give it to you. And so this would be the graph for y equals 4/3 x minus 5/3. And again, really shortly, we're going to learn how to do that. All right, so as you may or may not have figured out at this point, if you know one point on the line and the slope, we can easily graph any equation. And this is kind of the preferred method to do it. You saw kind of in the last lesson where we go through and make these ordered pairs. And even though with the intercept method, it's a little bit easier, this method of graphing is just so fast. So my given point is -2, 4, and my slope is -2. So again, m is -2, and my given point is -2, 4. So here's -2, here's 4, so that would be -2, 4. And if my slope is -2, again, that means that my rise over run is equal to -2 over 1. So that means I'm falling 2 units for every 1 unit I go to the right. So starting here, I would go 1, 2 down, and then 1 to the right. There's a point. 1, 2 down, and 1 to the right. There's a point. And once you have 3 points, really 2, you can draw the line, right? But 3, again, is nice to get a nice clean line. And I like to do a few more, actually, if I'm freehand. So 1, 2 down, 1 over. 1, 2 down, 1 over to the right. 1, 2 down, 1 over to the right. So kind of a faster way to graph a line. Okay, so another thing we want to talk about, let's say you get to your homework and you're presented with a graph. And so the graph of this line, they have some clearly indicated points, and it asks for the slope of the line. Well, using the rise over run kind of thought process, so rise over run, you can calculate it. So let's say you start out at one of the points. So this point right here looks like -6, 8. So -6, 8. All right. So you think, what would I need to do to get to the next point? So how much do I rise? So to get over here, I've got to fall, right? So I'm rising by a negative amount. I'm going down 1, 2 units. So right here is not the next point, but it's the same y location as the next point. So that means I'm falling by 2 units. And then I'm running over to the right, which is positive. I'm going over 1, 2, 3 units to the right. So my slope is -2/3. And then you can check that again starting at the next point. Down 2, 1, 2, go over to the right 3. 1, 2, 3. And I'm at the next point. down 2, 1, 2, over to the right 3. 1, 2, 3, I'm at the next point. Again, you can keep doing that. So our slope in this case is negative 2/3. And then one of the other ways you could check this, you could look at one of the other points. So this point right here is negative 3, 6. So negative 3, 6. And you could use your slope formula and see if you get a slope of negative 2/3. So let's do that real quick. So remember your slope formula, m is the slope. This is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, where x sub 2 does not equal x sub 1. And I'm just going to go ahead and label this first point as x sub 1, y sub 1, and the second one as x sub 2, y sub 2. And again, if you wanted to change that around, you get the same answer. So y sub 2 is 6. So I'm going to erase this and put a 6. Y sub 1 is 8. I'm going to erase this and put an 8. X sub 2 is negative 3. So I'll erase this and put negative 3. And x sub 1 is negative 6. So I'm going to erase this and put minus negative 6, or you can just do this right now and just say this is plus 6. So 6 minus 8 is negative 2, and negative 3 plus 6 is 3. So you get negative 2/3 as your slope, and again, that's exactly what you calculated here. Your rise over run is equal to negative 2/3, or negative 2 over 3. All right, so now that we have the basics down, let's wrap up our lesson with a few basic things that you need to know about slope. So the first thing is that a line with a positive slope rises as we move to the right. So that kind of looks like a line that does this, right? So as we move to the right, so as x increases, remember x increases going to the right, y increases. So as we go to the right, the line is increasing in value. So similarly, a line with a negative slope falls as we move to the right. So in this case, as x increases, y is now going to decrease. So that line would look something like this. So as x is increasing, remember x increases as we move to the right, y is now decreasing. Your vertical values are moving down as we go to the right. All right, let's talk about some special case scenarios. The slope of any horizontal line is always 0. So you have something like y equals 7. So you'll recall graphically, I just find 7 on the y-axis, and I draw a horizontal line. That's how I graph that. Okay, so this could be my graph for y equals 7. Now, if we think about this in terms of, again, rise over run, so rise over run. Just think about moving 1 unit to the right. So let's say I'm at this point right here, and I go 1 unit to the right. So my run is 1. What's my rise? It's 0, right? I'm not moving at all vertically. So I would have 0 over 1, which is just 0, right? Take 0 and divide it by any non-zero number, and you get 0. So this is going to be the case every time we see a horizontal line. So a horizontal line has a slope that is 0. So lastly, a vertical line has an undefined slope. This relates back to when I gave you the slope formula and I said x sub 2 could not equal x sub 1. Well, again, you subtract the same number from itself, and you get 0. Division by 0 is not allowed. So the change in x values will be 0, and division by 0 is undefined. So if I have a vertical line like x equals 2, you just say that the slope is undefined. So if I saw x equals 2 on a graph, remember I'd find 2 on the x-axis. So again, this is x equals 2. And if you think about this in terms of, again, rise over run. Just started at any of these points, and all of them are going to have the x location of 2. So let's say I started out at this point. So this is 2, 3. And I go to the next point above it, which is 2, 4. Well, my rise is 1 unit, right? Because I increased on the y-axis by 1, but my run is 0, right? My x location didn't change at all. So that's 0. And we're not allowed to divide by 0. This is undefined. This is undefined. So when I have a vertical line and they ask you for the slope, you just reply that it's undefined. Because if you go to try to calculate it, you're going to end up with division by 0. And once again, that's undefined.